Hi everyone, this is TSR. Now, in this video, we are going to discuss about few more applications of fundamental theorem of arithmetic using prime factorization method. So, what it explains us? So, this concept is related to exercise 1.3 based upon theorems 1.3, 1.4 and 1.5 in Telangana State Book. In cbse textbooks and in Andhra Pradesh textbooks, maybe theorem numbers may be different, but concept will be same. What it explains us, very simple concept and very important 1 mark 2 marks questions can be asked from this exercise 1.3. So please listen very carefully. I will explain in detail what the theorems explains. So we know that every rational number can be expressed in the form of p by q, where p comma q are integers, q is not equal to 0, right? But that rational number can be expressed in two different decimal forms. One is terminating decimal form, another one is non-terminating recurring decimal. How? If the rational number which is in the form of p by q is having its denominator q in the form of 2 power n into 5 power m, 2 power n into 5 power m, where n comma m are whole numbers, means non-negative integers, then in this condition the rational number gives terminating decimal. The rational number gives us terminating decimal. For example, 7 by 2. Here denominator is 2. So it can be written as 7 by 2 power 1 into 5 power 0, where the denominator becomes in the form of 2 power n into 5 power m, where n comma m are whole numbers 0, 1, 2, 3 and so on. You can take in the representation of the denominator q with the primes 2, 5 only, then its value will become 3.5. 7 by 2, after long division its value will become 3.5. Clear? So if the decimal ends with a digit, then that is called as a terminating decimal. Terminating means ending. Terminating decimal that can be identified when its denominator q is in the form of 2 power n into 5 power m. Clear, Anana? That means, please observe that logic. If the base is in the powers of 2 or 5 or 2 and 5 only, then that is terminating decimal. Okay, this is the simple example. If the denominator q is not in the form of 2 power n into 5 power m or 2 power m into 5 power n, it's your wish. If it is not in that form, then it represents non-terminating recurring decimal. Non-terminating recurring means repeating decimal. Okay, what it means? If the denominator of the rational number is not only in terms of 2, 5, if there exists any other prime number in its prime factorization representation like 3 or 7 or 11 like that, other than 2 and 5, if there exists any extra prime number in the denominator prime factorization representation, then it will not in the form of 2 power n into 5 power m. Automatically its decimal representation will become non-terminating repeating decimal. What is the simple example for that one? You take 2 by 3. denominator is not in the form of 2 5s, it is taking something extra, something else. Okay, so automatically its value will become 0.666 and so on. It will not end and so on, it will not end. If it not ends, that is called as non-terminating. And in the decimal part, the digits will come repeatedly 6666 in some of the numbers, 1 2 1 2 1 2 1 2 like that. That is called recurring or repeating. So once again I am explaining, in the p by q form rational number, denominator q is not in the form of 2 power n into 5 power m. If it is taking some other prime numbers, automatically its decimal representation will become non-terminating recurring decimal, not ends, but the decimal part digits will be repeated. 1 digit may be repeated, 2 digits may be repeated, 3 digits may be repeated, like that. This is called simple decimal representation of a rational number using the theorem statements 1.3, 1.4 and 1.5 totally explained. Is that clear, Nana? Right. Now what is the use of discussing all these numbers? So with the help of this simple concept, we can solve the exercise problems of 1.3. okay, so from that exercise 1.3 I will take few few problems which are very important for examination point of view. So let us discuss them. So if you observe that exercise 1.3, in that the most important points will come from second bit. In second bit, few there are many problems are there, almost 10 problems are there. Among them I will take 2 to 3 problems. First one is sixth problem, and the next one eighth problem, and the next one ninth problem. Along with this we will take fourth bit second problem. So these are very important for public examination point of view. They have a chance to ask for 1 marks, 2 marks. Fourth bit models may have a chance to ask for 4 marks questions also. So please listen to them very carefully. In the second bit, the question is without performing division, without doing long division, state whether the following rational numbers will have a terminating decimal form or non-terminating repeating decimal form. Without doing long division, they are asking to tell whether they are terminating or non-terminating repeating. For that, just we have to observe only one thing, that is what is the denominator form. Is it in the form of 2 power n into 5 power m or not? By that we can decide. So in this sixth question is given number 23 by 2 power 3 into 5 square. 23 by 2 power 3 into 5 square. Very clearly in the question itself the denominator is given as 2 power 3 into 5 square. So it is in the form of 2 power m into 5 power n. Automatically it can be written in the terminating decimal form. They are not asking what is that terminating decimal form. Is it terminating or non-terminating repeating? That only they are asking. So given number is 23 by 2 power 3 into 5 square. This implies the denominator is equal to 2 power 3 into 5 square in the form of 2 power m into 5 power n. Therefore it is a terminating decimal. Terminating decimal. Is that clear, Nana? Right. Sometimes they can extend the problem for extra marks. What is that terminating decimal? Also they can ask. So I am extending that one. In this problem they did not ask, but sometimes is it terminating decimal or non-terminating repeating decimal? Justify your answer. If it is terminating, find its value, they can ask. Like that they can ask. So how to find out that terminating decimal? That is extension. Very simple one. That one is 23 by 2 power 3 into 5 square is the problem. To find out their decimal values, we have to do one extra calculation. That one is try to make the powers of 2 and 5 same. Try to make the powers of 2 and 5 same. Dear children, please observe that in the regular classes we can repeat, we can revise the important points, but in the video classes, without lagging, without wasting time, I will explain that point clearly in the running. So if you want to revise it, just revise the video. Okay, Nana? Right. So 23 by 2 power 3 into 5 square. What I said, make the powers same with suitable multiplication. Here 2 power 3 is there, here 5 square is there. Extra 5 you multiply to numerator and denominator, you will get equivalent fraction. That is 23 by 2 power 3 into 5 square into 5 here into 5 here. By this it will become 23 times 5, 5 3s are 15, 1, 5 2s are 10, 1, 115 by 2 power 3 into 5 power 3. That will become, denominator will become 10 power 3. That is the feasibility. For that only, we are telling that the denominator should be in the form of 2 powers and 5 powers only, because those are the prime factors of 10. So the denominator can be expressed as 10 powers. 10 powers, 10 means deci. If the denominator is in 10 powers, automatically number will become decimal form and it will terminate. So that is 115 by 10 cube, that is equal to, from right side to left side, after 3 places you take the decimal point, because it will become 115 by 1000. 3 zeros are there, therefore it is equal to 115. From right side to left side, 1 2 3 digits, take dot, therefore its value will become 0.115. So the conclusion is 23 by 2 power 3 into 5 square, decimal form is 0.115, terminates with 5. So the number is a terminating decimal. If you want to calculate, this is the process by making 2 5 powers same with suitable multiplication, convert the denominator into 10 powers and finish the problem by getting terminating decimal. Is that clear, Nana? In the examination point of view, most of the times they will ask to find out the terminating decimals only. Non-terminating repeating decimal values, they don't want to ask to find. Remember that one. Thank you. So after this problem, we will enter into the next one, 8th question. What that 8th question is, just observe that. The question says 9 by 15. 8th question is 9 by 15. We have to tell whether it is terminating decimal or non-terminating repeating decimal. For that, we have to focus on denominator. That process I explained in the previous problem. But sometimes there exists some logical condition. What is that? Before going to observe the denominator, whether it is in the form of 2 power m into 5 power n, we have to do one more checking process. That one is, is there any cancellation possible between the numerator and denominator? Because in the theorem 1.3, 1.4, 1.5, they told us P by Q are integers and coprimes and Q not equal to 0. Coprimes. That one in the previous explanation I did not given. Here I am trying to give that one. So before going to check the denominator, check is there any cancellation is possible or not. Actually 15 prime factorization is 3 times 5, 3 into 5. But there is a cancellation. 3 table will get cancelled. 3 3s are 9, 3 5s are 15. Okay, Nana? Okay. In this denominator is 5. So you can write this one as 3 by 2 power 0 into 5 power 1. Automatically it is denominator equal to 2 power 0 into 5 power 1 is in the form of 2 power m into 5 power n. Therefore it is a terminating decimal. Terminating deci. Is that clear, Nana? Right. If you want to find its value, what is the terminating decimal value? Already I told you, na, make the denominator to 5 powers same. Therefore 3 by 5 is actual given rational numbers original value is equal to 3 by 5 into 2 in the denominator into 2 in the numerator. To make the 2 5 powers same, automatically this will become 6 by 10. This is equal to 0.6. Do you know that one? It is a terminating decimal, which is a terminating decimal. Is that clear, Nana? This is one more model. Check whether the numerator and denominator are having cancellations or not. Make them coprime and observe the denominator, write its form and conclude the answer. Okay. If denominator is not in this form, if any extra prime numbers are remaining 3, 7, 11 like that, then it will become terminating, non-terminating repeating decimals. Clear, Nana? So that model, one more problem we will take, that is 9th question. They are telling 36 by 100. 9th question is 36 by 100. Directly I am writing. So check that some cancellations are possible. First of all, cancellation means their HCF will get cancelled. If you are able to find out that HCF direct cancellation, you can do. Otherwise, both are even numbers. With 2 you divide them. 2 18s are and 2 50s are. And again both are even numbers. One more time cancellations. 2 9s are, 2 25s are. Now this is equal to 9 by 25 without cancellation, without possibility of cancellation. Both are coprimes. 9 by 25. Now it is equal to 9 by 5 square. 5 square. Therefore denominator is in the form of 2 power m into 5 power n. Therefore it is a terminating deci. Okay, Nana? Right. One more time. Like this, cancellations. Okay. What is the terminating decimal value means? Therefore, that one I am telling, Nana. Please observe this. 9 by 25 is equal to 9 by 5 square. Already we got. Already I told you, na, take 2 power 5 power same in suitable multiplication. So that is 9 by 5 square into 2 square into 2 square in numerator and denominator. Therefore it is equal to 9 into 4 by 10 square, which is equal to 36 by 100. It is coming. Means you observe that actual process I am explaining. Actually we got it as 36 by 100. Original value only, but calculations coming like that. Okay, denominator is 10 powers, so it is terminating decimal. How many zeros are there? 2 zeros. So write 36 from right side to left side. After 2 digits, take the decimal point. It is 0.36. Its original value is 0.36. Is that clear, Nana? Right. So actually, I supposed to give non-terminating recurring model. So for that, I will try to take fifth question, Nana. Fifth question. I am including that one. What is that number is 29 by 343. 29 by 343. Okay, right. Now this is equal to 29 by 343 is 7 cube. 343 means 7 cube. Okay, in prime factorization. That one we learned already in the earlier class. So, and no cancellations are possible. 7 is not a factor of 29, so cancellations are not possible. So, denominator is equal to 7 cube, which is not in the form of 2 power m into 5 power n. Therefore, it is a non-terminating repeating decimal, like this. In exam, you can include few more points also, how I had given in that first question. So in that model, given number is something like that, you can include, just add the clear explanation to the problem, but actual process is this one. So in this way, we can apply the theory of theorem 1.3, 1.4 and 1.5 to tell whether the given rational number is terminating decimal or non-terminating recurring decimal model, and from that we can find out their decimal values also. Is that clear, Nana? Right, very good. After this, the most important one is third Roman, also same continuity, Nana, finding the decimal values only. That's why I am not touching them, because I am going to fourth question. What is that fourth question? Says the question is, express the following decimals in the form of p by q and write the prime factors of q. What do you observe? So they are asking its reverse method problems. Decimal values they are giving and they are asking to express us in the p by q form. Decimal values they are giving like this, they are asking its p by q forms. Okay, and they are asking to write the denominator in this model. Okay, na? Users, apply your skills to do the new problems with numerical changes. Right, coming to the fourth question, if you observe that they are asking to express the given decimal values in the form of p by q, rational form. Actually, same model questions are there in 9th class and they are repeating it in 10th also. So focus on that. The first question we are taking from this fourth one is second one. What is that one? That question is 43.12 bar. 43.12 bar. 12 bar. This is the given decimal value. Okay, we need its p by q value. So I will explain that one neatly. Just observe that. First write given number is 43.12 bar. Clear? Let us suppose this one as x equal to 43.12 bar. 12 bar means non-terminating repeating decimals will have this form. Whatever the repeating digits are there, without repeating them continuously, we can write this bar symbol. Its meaning is it is equal to 43.12, 12, 12 and so on. Let us suppose this one is equation 1. try to give little gap between repeating digits to identify them easily. Clear Anana? So how many digits are under repetition means how many digits are having bar? Here 2 digits are having bar, so those 2 digits are under repetition. That's why here the periodicity is 2. So multiply with this equation with 10 power periodicity, that is 2. If it is 3, with 10 power 3. If it is 4, with 10 power 4. If it is 1, 10 power 1. With that value we have to multiply. Means what? With 100 we have to multiply the equation on both sides. So multiply with 10 power 2 equal to 100. Therefore equation 1 implies 100 times x. 100 times x equal to 100 times, means here I am writing multiplication symbol, 100 into 43.121212 and so on. Therefore it is equal to 100x equal to, if you multiply 100, automatically decimal point will move 2 steps to the right side. Therefore it will become 4312.1212 and so on, because repetition is there, that's why. Let us suppose this one is equation 2. So 100x is bigger value, that's why I am trying to subtract equation 1 value from equation 2. So equation 2 minus equation 1 implies 100x is equal to 4312.121212 and so on. X equal to 43 dot, you write this number, decimal number properly. Means what? You are not allowed to write mathematics in your own way. There are some rules and regulations, unit digit, tenth digits, like that. Equal to implies, therefore, you have to follow all the rules. How we will drive on highways, what rules we have to follow for our safety. In the same manner, in mathematics also you have to follow the safety measures, otherwise you will lose the marks. So write the decimal value in order, means unit digit, tens digits, like that. Remaining value 1 2 1 2 1 2 and so on. Now subtract them. Therefore 100x minus x is 99x is equal to 4312.121212 minus 43.121212 and so on. So decimal parts are same, that's why subtract them, cancel them. Then the remaining value, only this integral part. 2 minus 3 will not go, so borrow the number. So 12 minus 3 is 9. Here 1 will become 0. 0 minus 4 not possible, so borrow. 10 minus 4 6. 3 becomes 2 and it is 4. That's it. Therefore x equal to 4269 by 99. But confirmly this may be not the final answer. Okay na? So check, is there any cancellations are possible between the numerator and denominator. If there, cancel them. Here you see 99 is a 3 multiple or 9 multiple, so and 11 multiple. Check that procedures. Here 9 plus 6 15 plus 2 17 plus 4 21, it is a 3 multiple. So with 3 you can cancel them. This is equal to 33. This will become 3 1s are 3 4s are 12, 3 2s are 6, 3 3s are 9. And again check that one. 3 plus 2 5, 9 10. 10 is not a 3 multiple, so this is the final answer. Correct? So further cancellations are not possible. Therefore given decimal value 43.12 bar is equal to 1423 by 33. This is its decimal conversion. Is that clear, Nana? Okay.